Okay. So we're going to start talking about some different things. Oh, good Lord. Things to remember. I have a little cheat sheet at the top, or we have a little cheat sheet at the top of all how to find different notations. So number one says, what does CPCTC stand for? I'm not going to write this out. I'm just going to go through it verbally, but CPCTC is corresponding parts of congruent triangles are congruent, which just basically says if I know two triangles are congruent, then all of their corresponding parts are congruent. Okay? Number two, it says use the congruency statement below. Label the picture using the arcs and tick marks to show which pieces are congruent. So this is a show your work one. You just go in and you'd say, okay, if I know y, x, w is congruent to t, u, v, then I know, well, y has three little arcs. And so that's going to be the same as t, so t is going to have three little arcs. Okay. If x has two arcs, then u is going to have two arcs. And if w has one arc, then v is going to also have one arc. Okay, that's the first thing. Then you look at the sides. I have yx, so yx is 3 marks, so tu is also going to have 1, 2, 3 marks. XW, so XW has 1 mark, so UV is going to have 1 mark, which means that this one is going to have 2 marks. And that's all you have to do is just kind of show with the congruence. Next one, write a congruency statement. Just be really careful. There are a lot of different answers for this that we'll accept. So I just start with the first triangle. I'm going to say triangle XYZ, or let's say XYZ is congruent to a triangle. Now I'm really careful. I'm like, okay, well, X has 2 arcs, so Z has 2 arcs. So it's going to start with Z. And then my next one is Y. Y has 1 arc, so K has 1 arc. So it's going to be K. And then the last one is, well, Z has 3 arcs, J has 3 arcs. Z has 3 arcs on the other triangle. And so any different combination of that is also going to be true. So you have triangle XYZ and ZKJ. You could also have triangle YZX is congruent to triangle KJZ. Okay. Or you could have triangle ZXY is congruent to triangle JZK. Okay, so just make sure that the corresponding angles are in corresponding parts. So when I write it in here, this is where you have to use your notation. This just takes me a little bit just because I'm using an iPad. So I know I'm going to do this, and then I'm going to write the word triangle. I press the space bar, a triangle comes up, and it's XYZ. So I just make sure that's capital. If you don't, that is wrong. XYZ. And then I'm going to do the same thing. I'm going to do this backslash. I'm going to do CONG, congruent to. Then I'm going to do that backslash again. Triangle. And then I'm just going to look up here. It's ZKJ. Okay, so ZKJ. All right, and then that's one possible answer. Any sort of variation will be fine as well. Okay. Select all the postulates and theorems that can be used to prove triangles are congruent. Side, 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 angle, side, angle, side, and hypotenuse leg. The other are and angle, angle, side. Angle, 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 and side, side, angle are not ways to prove congruence. Use the given information to complete the statement. Okay. So I like marking everything. So I know that BA is congruent to BW. CA is congruent to CW. I also know that BC is congruent to BC. So I know that these are congruent by side, side, side. And so I know triangle ABC must be congruent to triangle, and now I look, A is the same as W, B is the same as B, and C is the same as C. And so when I write it in here, I'm going to write triangle. I write the word triangle. If I don't have that, it's wrong. And then it was WBC. Make sure you use capital letters. I can do a comma, and I know that's by side, side, side. And you can write side, 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 congruent, or whatever. Okay. In the diagram of this quadrilateral, you're given a whole bunch of information. Which method can be proved that ABC is congruent to CDA, and why? So this is an essay form. So I know angle ABC. So this angle here is congruent to CDA. That's one thing that I know. I'm also, what else am I given? I'm given AB is parallel to CD, and that's it. Okay, I know that AC is congruent to itself, so that's another piece of information that I have. I also know, because those are parallel, I know that this angle here, angle BAC, must be congruent to this angle here, angle DCA, because they're alternate interior angles. So these are going to be, I can prove these congruent by angle, angle, side. Okay. So in the so that's what you're going to talk about. So it says explain thoroughly. So which method can be used? You'd write, well, angle, angle, side can be used. And why? Because AC is congruent to AC, reflexive property. I know angle DCA was congruent to angle BAC. So I knew that these two angles here and here were congruent. Put that in your explanation because their alternate interior angles were congruent. Actually, this is not a great color, is it, guys? So alternate interior angles are congruent. So, and then this was because reflexive property, so you're just going to put all of that in your explanation. I know that AC was congruent to AC because of reflexive property. Alternate interior angles were congruent, so that made it so it was angle, angle, side. Okay. But you need to make sure you have that language, alternate interior angles, all of those things. Okay. Determine if each of the following conditions are sufficient to prove that the two triangles are congruent. Two sides of one triangle are congruent to two sides of another triangle. This is actually going to be a big no. You can, if it is not sufficient, explain your reasoning. No, you need three things. I don't want to say things. You need three parts. There we go. To prove congruence. Okay. Next one, if three sides of one triangle are congruent to three sides of another triangle, that's going to be yes, that's side, side, side. Okay, so we don't have to do it. Three angles of one and three angles of another. This is going to be no, because the sides could be different sizes. Okay. Number 10, yes. This is going to be yes. Okay, and then here we have a few proofs, and that's just what we're going to kind of end with. So all 6 parts are congruent. Yep. Okay, so let's go through this proof together. All right, rated 2-column proof. It's given that S is the midpoint, so of QT, that's given. And you're also given QR is parallel to TU. That's also given to you. So there's a few ways to do this. I'm going to do it just one way. I'm going to first use the first part. So S is the midpoint of QT. So if S is the midpoint of QT, then I know QS must be congruent to ST. And that's by definition of a midpoint. Okay. So that's one thing. I need at least two more things. But I'm also given QR is parallel to TU. Since that's true, actually, angle Q must be congruent to angle T. Okay, that's going to be alternate interior angles theorem. And you also know, because those angles, or because those lines are parallel, that angle R must be congruent to angle U. Also, alternate interior angles theorem. And once you have that down, yes, you can use vertical angles. So your reasoning might be a little bit different. Maybe you put vertical angles here instead of this. I just use alternate interior angles twice. And so I can say that triangle QSR must be congruent to triangle TSU because of angle side congruence theorem. Okay, but if you use vertical angles in that one step, you would yours would actually be angle side angle, so it might be a little bit different. All right, so that's the first one. So we have two more. Okay, another proof. All right, you're given AB is, ooh, I almost put congruent. AB is parallel to CD, so you know you're going to be talking about angles. That's given. You're given BC is parallel to DE. That's also given to you. So I can't really write anything yet. You're given that CD is congruent to AB. So I am actually going to mark that in my diagram. So I know this one is congruent to this one. Okay? And so I need at least two more things in order to prove congruence. So for this, I kind of fixate a little bit on my parallel lines. So I'm given that AB is parallel to CD. So what I'm going to do is I'm just actually going to kind of make those sides a little bit longer. And I look at a couple of things. I look at the transversals that are created. So there's one transversal here, but I'm looking at this and none of my angle pairs, like these would be alternate interior. Well, that's not going to be helpful because this angle is not in this triangle here. I know corresponding, well, that's on the outside. This would be corresponding. So what I'm looking for is a transversal where my angle pair, alternate interior, alternate exterior, corresponding, consecutive interior, not consecutive interior, are both in the triangle. So I'm actually going to kind of backtrack and get rid of that one transversal. Okay, so now I look at, well, I have a second transversal for these, and that's this one right here. And so I kind of ignore all of my other lines and I look at that right there and I'm like, oh, okay, well, I got it. I know that this angle here must be congruent to this angle here because those are corresponding angles. So I know that angle BAC must be congruent to angle DCE by corresponding angles postulate. Okay, and so that's the first thing. Now I have two things. I have one thing here, two things here. Okay, let me, I'm going to delete. There we go. All right. So now I look at the other piece of information. I'm also given that BC, ooh, did not mean to do that. Okay, there we go. Back to scribble. I know that BC was parallel to DE, so I'm gonna do the same thing I did with the other ones. I'm gonna make BC and DE really long. I'm gonna look at my transversal here. That's not very helpful because again, it's still the same problem. I don't have any angles in common that are in both triangles, so that's not going to be very helpful. So then I have a second transversal here, a line that cuts through these lines. And I notice that, and I try to ignore everything else, and I know that's kind of hard, that this angle has to be congruent to this angle. And those are also corresponding angles. So I know angle BCA must be congruent to angle DEC. Okay, also corresponding angles postulate. So I get rid of all the rest of that information. You guys are capable of doing the same thing. Do I have enough information to prove these triangles are congruent? Well, indeed I do. Okay. So it's going to be, I know triangle ABC must be congruent to triangle CDE. Okay, and why is that? Well, that's going to be by angle, side congruence. Okay, knowing that, now I have enough information. Well, if those triangles are congruent, all their parts are congruent, so I know that AC must be congruent to CE, because corresponding parts of congruent triangles are congruent. All right, last one. Okay, this one's a little dicey. So it says BA is perpendicular to DA. Okay, so BA is perpendicular to DA. BC is perpendicular to DC. These are both given. Okay, and you also know AB is congruent to BC. That's also given to you. Okay, and so BD so you're trying to prove that BD bisects angle ADC. Okay, so I have one more piece of information here. I know that BD is congruent to BD. That's reflexive property. Okay, and for this, I know that I have a hypotenuse and I have a leg, and these triangles are right. So this isn't angle side side. This is actually going to be, or side side angle. This is going to be, I know that triangle ABD must be congruent to triangle CBD by hypotenuse leg theorem. And you can write it out if you want. Okay. Now we're trying to prove that BD bisects angle ADC. And so I know that that's going to be my last line. I'm actually going to just leave a little space. So BD bisects angle ADC. Well, I think about what bisect mean. Well, bisect means it's cut into two congruent parts. So are these two parts congruent? So here we have our angle ADC. Is this part congruent to this part? And yeah, we know it is. I know that angle ADB must be congruent to angle CDB. Okay, because corresponding parts of congruent triangles are congruent. So BD must be the bisector because these two parts are congruent. And so my reasoning here is going to be, well, definition of bisect. Okay, because we've shown that it's cut into two congruent parts, so it must be a bisector. And that is that.